Hello everyone, welcome to my channel. Today we are going to solve Leetcode problem number 94, that is binary tree in order traversal. So let's get started. So in this problem we are given the root of the binary tree and our task is to return the in order traversal of all the nodes. So before writing the code, let's understand what is in-order traversal actually means, and then we're going to perform a complete dry run on this tree. So let's get started. So basically we need to know what is in-order traversal. So in order traversal, we're going to follow this rule, which is left, then we're going to consider the root and then the right. It means we're going to visit the left subtree, then we're going to visit the current node, and then we're going to move towards the right subtree, right? So let's suppose if we have this tree, so what we're going to do is, we know that we need to move, we need to traverse. First of all, we need to move towards the left side of this tree, right? Okay, so I'm gonna take this. Yes. So right now, this is the main node, right? This is the root node, we can say, and this is what the left side of this root node, and this is what the right side. So according to this order, we need to move towards the left side of this root node, right? Which is this, right? This is the left side of this root node. Now if we're going to see, we have further two child of this node, which is the right child or the left child, right? It means it's work like a root node for this subtree, right? It means we need to again move towards the left side of this root node, which is this is 4, right? Okay, now if we're going to consider a root node for this, let's suppose, so we don't have any other node, right? We don't have any left child or right child for this node. So what we can do, we're going to add this number. This is the leftmost part of this whole tree, right? So we're going to add this. So I'm going to write over here like 4, right? Okay, then after left side, we need to consider the root node. So what is the root node of this fourth node? Which is this? This is 2, isn't it? So I'm going to write over here 2. And after that, we need to consider the right node. So according to this subtree, what is the right node? Which is this, right? So I'm going to write over here, which is going to be 5. Okay, so we have completed with this subtree, this one. And if you're going to see, this is the main root node. So we have already traversed through all the node of this main root node, right? We have already traversed all the left side of this main root node, right? So after that, left side, what we need to do, we need to consider the root node, which is this one. So I'm going to write over here 1. It means after that, we're going to connect it through this 1. And after root node, we need to move towards the right side, which is this, isn't it? So we need to write the 3 afterwards. And that's it. This is how we need to solve this. So basically, we'll again going to use a recursion, right? So let's see the coding part. Okay, so we need to return the list, right? So for that, I'm going to make a result list. So it would be like this, result, then it's going to be list. And then as we know, we're going to perform a recursion. So for that, we need a helper function. So I'm going to make one function, which is going to be def. I'm going to name them in order. So it's going to be easy to identify. Then again, we're going to pass a node. And then we're going to check that if that node is null, let's suppose if I'm going to move further, look it over here. If I'm going to consider this node and I'm going to move further, so we don't have any other node, right? It's going to be null. The left child of this node is going to be null and the right child of this node is going to be null. Similarly for this node and similarly for this node. So this is what the edge case is, right? So that is why we need to consider this also, that if that node is null, so we're going to simply return, right? So if not node, then we simply going to return. Okay, now let's move ahead. As we know, we need to traverse the left side of this tree first, so we're going to call this function again, which is going to be in order, and this time we're going to pass node dot left because we need to traverse the left side of this root node, right? Then after that we'll need to append the root node, right? So I'm gonna append this directly to the result, which is going to be result dot append node dot fill. Okay, and then we need to traverse the right side of this node. So I'm gonna write over here in order. This time we're going to pass node dot right, right? And then again we need to call this function, right? So I'm going to call them in order. We're going to pass root, and also we'll need to return this result. So return result. That's it. So let's run this code. Accepted. So before submitting this code, let's see the dry run of this. All right, so we have I'm going to take a simple tree and let's start it. So first of all, we're going to pass a root, right? Root node. Look over here, we have passes the root node, right? So that is fine. So we're going to pass a root node, which is going to be 1. So I'm going to pass over here 1 in this function, and then we're going to check this whether this node is null or not. So yes, this node is not null. So we're again going to call this function, right? I'm going to call this function again, and this time we're going to pass node dot left. What is the left node of this main node, or we can say root node, whatever. So what is the left node of it, which is going to be 2. So I'm going to pass over here 2, and then again we're going to check whether this node is null or not. So no, this node is not null at all. So again we're going to call this function, and this time we're going to consider the in order node dot left. So what is the left node of this second node, which is going to be 4. So I'm going to pass over here 4. Then again we're going to check whether this node is null or not. So no, this node is not null. Then again we're going to call this function. Okay, so again we call this function, and this time we're going to pass node dot left. So do we have a left child for this fourth one? No, we didn't have. Means we are just passing the null value this time, isn't it? So again we're going to check, is this node is null? So yes, this time this node is null, right? So we're not going to move further, means we're going to return this part, means this part is finished. Now we're going to append this result dot append node dot well. What is the node dot well? Which is going to be 4. So I'm going to append inside our result. And then again, means this function is done, means again we're going to pass in order node dot right. So what is the right node of this node? Which is going to be again the null value, isn't it? So I'm not calling this function again, right? It is obvious. Okay, so this function is done, means we'll need to move towards this function, means this function is done. Okay, then we're going to append result dot append node dot well. What is the value of this node, which is going to be 2? So I'm going to write over here 2. Then again we're going to pass, means this function is done, means we are going to traverse through the right node, which is going to be in order node dot right. What is the right node of the second node? Which is going to be this 5, isn't it? So basically we're going to call this function again, right? And again we're going to consider the left side of this 5 node is again null. Then we're going to append this node, which is going to be 5. And what is the right side of this node? Fifth node, which is again null, right? So it is obvious, so I'm not doing this again. Okay, now so we have already traversed through all the node which is situated at the left side of this main node, right? So we're going to append result dot append node dot will. What is the value of this node, which is going to be 1? So I'm going to append over here 1. Okay, now this function is also done. Now we're going to call this function again, and this time we're going to pass node dot right. What is node dot right? Which is going to be 3, right? Then again we're going to call this time we're going to pass 3, and then again we're going to check whether this node is null or not. So this node is not null. We're going to check node dot left, so we have null. Then we're going to append this value, so I'm going to append this value, and then again we're going to check node dot right, which is again going to null. Right, so this is how the try runs going to be, and I think it's very simple to solve this question through recursion, right? Calling this function again and again. So let's move again towards the coding part, and this time we're going to submit this code. So let's submit this code. So basically the time complexity of this algorithm is going to be bigger of n, right? Because we visited exactly once, each node will visited, and also the space complexity is going to be big of n also, because we are going to use a recursion, right? So recursion uses all the stack memory. So that's the complete solution for Leetcode 94, that is binary tree inorder traversal. And if this explanation helped you to understand binary tree traversal, so don't forget to like this video, subscribe to my channel, and share it with your friends. Thanks for watching, and I'm going to see you in the next video. Bye bye.